All right, so this video is just going to be a quick example showing you the most fundamental problem associated with this new unit. All right, it's called a mole-to-mole conversion. So you should have this diagram like we discussed in class, like I just talked about. And the point is that you're going to be watching this just during class after we've just talked about this for a little bit. Now, the actual problems. The big new thing with this unit is that from now on, you're not just doing, so you remember we were doing like mole conversions where it was like, okay, convert grams to moles, moles to particles, stuff like that. We're not doing that anymore by itself. Now we're going to be involving a chemical equation as well, that's kind of the point of everything here. Without the equation, there's no point to doing any of this, really. So here's an example equation. And what we're going to do, the equation basically represents like a recipe. The coefficients tell you how many ingredients of each thing you need, what they combine into, and then you see what they're made, or what they make. Now, for this purpose, pretty much all you're going to need to do, these are not hard problems. They'll get much more complicated. But it's important that you follow the steps, that you write it out correctly, and that you show your work, just like I am showing it. That's really important. Please do that. Otherwise, it's just not going to go well for you, and you need to do that. All right. So, to show your work correctly, properly, all that, here's how we'll do this. To begin with, so you're going to have this reaction. Let's give you like a sample problem. Let's say, and I'm going to like draw it out on here, so it's not, you don't even have to read anything. So let's say we have 40 moles of H2. We have 40 moles of H2, and we want to convert that to moles of H2O. So that's the sort of the basic problem right there. Now, the way this might be worded, you might see a problem that says something like this. If you have 40 moles H2 excess O2. All right, so that's the type of problem that you might see written out reasonably clearly in terms of the wording. So if you have 40 moles of H2 and excess O2, how many moles of H2O can be made? Now, what is this excess thing? What is the deal with that? Where'd that come from? Well, basically the way you're going to do this, so you've got a reaction, and I'm going to rewrite it right here. So you got to think of this as a reaction, and you need, and remember, these are our reactants. This is our product. So you need both of these things to make the product. When one of these things runs out, the reaction stops. Now, later we're going to be doing calculations where we figure out which one runs out first, and then how much we can make from there. All right, now if you think back to the example I just showed you, it's like, if you can only make so many cakes based on the ingredients that you have. When you run out of one ingredient, the rest you stop. I mean, when you run out of eggs, you can't make any more cakes. It doesn't matter if you got all the flour, all the sugar, all the oil in the world. If you got no eggs, according to the one recipe that you're using, you can't make any more cakes. Same deal here. You can have all the oxygen in the world, but when you run out of hydrogen, you can't make any more water. So in this case, this is done for us. So this says we have excess oxygen. Now, excess. Whenever you see the term excess, that means you're going to ignore it. That means you're going to completely ignore that part of the problem. So that means our oxygen doesn't matter. We got enough of it. We don't care. We don't have to worry about it. It's not running out. That's the problem's way of saying it's not the limiting factor. It's not the limiting reactant. It's not the thing that's going to run out. Instead, we know we have 40 moles of H2. You can abbreviate it as MOLE or MOL. I usually use MOL, but I'll try to be thorough. Avoid questions. Because of that, I'll write it like that. And then it says, how many moles of H2O are we going to get? Now, I set this up like this for a reason, because once you get to this point, the rest of it it's really simple. All right. So what we're going to do, we're going to write it out like this. We're going to write 40 moles of H2. Back to this again. Remember, whatever we have here, whatever we put here, we're putting down here as well, always. Always, that just gets copied down. And then the new step, the new thing you're trying to find moles of H2O. Now, on this chart, all right, now looking at this chart, this thing here, like, so I talked about this chart a little bit, but just specifically showing you where this problem fits in. You are currently at moles of A, and you're going to convert to moles of B. All right, that's what we're doing in this reaction. So we have moles of one thing, we're converting to moles of a new thing. All right. You're going to use this, you're going to multiply by this conversion factor. And you notice it doesn't say what it is, and that's okay. What it is, it's the coefficient, all right, ratio. So it's the coefficient ratio. Now, what is the coefficient ratio? What does that mean? Well, it's really simple. That's a nice bell. That woke you up right there. Sorry, school rings random bells. Now, the way you'll do this, and this is why I label everything. So this is why you need moles H2, moles H2O, because you won't goof this up otherwise. Now, for this problem, it's really simple. But for future problems, less simple. And you'll see why I'm laughing in a second. So what I mean by this, these numbers, where do we get numbers for this? Well, this is the first time that there always used to be one of them was a 1. That's not the case anymore. From now on, the numbers are whatever the coefficients in the equation are. So you see how this is H2? And that's H2. So I'm going to copy the coefficient for that one right here. 2 moles of H2. I got H2O. I have a 2 there. Wow, I wrote that arrow too far. I'm going to put that 2 right there. All right. So these are just the coefficients. Just the coefficient. So in this case, you notice it doesn't change anything. It's just 40 times 2 divided by 2. Cancel out your units. You're left with just 40 moles of H2O. That's your answer. And that makes sense if you think about it, because it's like, look, it's a 2 to 2 ratio. If you have 2 moles of H2, you get 2 moles of H2O made, so it should be the same value. All right, and it works. It works because, we know our coefficient ratio, and that's what we need to pay attention to. Now, another example, we'll use the same equation. You don't always have to go to the product. You can do reactants to reactants. So we'll do another example like that. So next example. So we'll say if you have 36 moles. So there's the next example. Now, in this case, we're going to use the same equation. And there's always got to be an equation for these problems. So if you don't have an equation, and it's asking you something like this, well, then you're probably expected to write the equation, or you just don't see it somewhere, because it should be there. So in this case, we're told we have 36 moles of O2. So we have 36 moles of O2. And we want to know how many moles of H2 can we get. So you got 36 moles there, and we want to know how much of that. Notice the product doesn't matter at all in this case. It doesn't play a role. So you set it up the exact same way as the other problem. You write 36 moles O2. You write moles of O2 over here, moles of H2 over there. Again, this gets copied down there automatically, and then our goal, question mark, is the thing we're putting up there. So in this case now, coefficients. What is our coefficient for oxygen? There's nothing there. So if there's nothing there, you can assume a 1. All right, so you can assume a 1. So I'll even write it in there just to show you. So that goes there, and then this 2 for H2 goes right there. So I'm just showing you again, those are just showing you where those numbers come from. So it's coefficients. So you cancel your units out now. 36 times 2 gives us 72 moles of H2 are required. And that makes sense because this reaction shows you need 2 moles of H2 for every 1 mole of oxygen. So if you so basically the amount of oxygen, whatever you have, you're going to need double the moles of hydrogen to make water, which makes sense because H2O. So like 2 H's to 1 O. It makes sense. That's the point. It all sort of fits together. And again, this is the conversion factor ratio right there. And there you go. That's the beginning of this. Now it will get more complicated. You're going to have practice problems to do. What we'll do next after this, we're going to go mass to mass. That'll be a little more confusing. And we'll just see how this goes. All right. But that'll be for the next video. So good job.